All right. Well, sorry for the false start this morning. My upload speed is horrendous, and so I was getting a ton of dropped frames trying to go at 60 frames per second, which I love to do. I just think it looks a lot better, but don't have the option today apparently. So I had to drop down to 30. Okay. Let me get back on track with what I was looking at yesterday. So quite a few things need to get fixed today. I think I mentioned yesterday things I was not in the right headspace. So we'll have to fix some bugs first. Some of them fairly obvious in retrospect, but that's how it works sometimes. Okay. So last stream yesterday, I began the insertion logic for our tree. But first things first, I want to make a few clarifications. The initial implementation is going to be just a naive binary tree. I'm actually not going to do the Patricia compression at first. This is something I often forget, just because this is like one of the only use cases where I even think about this stuff these days. So I tend to conflate the two. But a Patricia tree is different from a naive binary tree in that it effectively it takes shortcuts. And what I mean by that is there's a few ways you can implement this, but in general, what happens is you effectively skip nodes either during insertion or during traversal during lookup, or I guess you'd have to sort of do a form of both, where if you have bits in common with all of the other prefixes that you've stored, then you don't need to store nodes at those those intermediate bits, which makes sense. You're kind of saving space. However, that leads to some potential false positives on lookup, and so you have to sort of mitigate that by doing a sort of out the door check. So there's some things that we'll need to take care of there. But the one thing I wanted to clarify is that right now the approach is not using that. What I'm going to do is change the implementation plan a little bit to just save that for later. So I think probably going to put that not at the very end, but I kind of wanted to get to the point where I have some benchmarking in place first. So more than likely we'll want to put it right here. Yeah. So yeah, actually skipping certain nodes during traversal. So like one way you could do it, and a common way to do it, is to actually store like what the next bit is. So like on insertion, if you know that the next 5 bits are the same for all of the routes that you have stored, then you store that actually in the node. And so when you're traversing the nodes, you look at that field and you say, oh, normally I would just iterate 1 bit at a time, but this node tells me that I can skip 5, so I'm going to do that. And so yeah, that's sort of one of the ways you can optimize that. Anyway, that is for future me to take care of. The other things that we did, really the basics of like the insertion logic. I didn't even get to the point where I was doing any lookups. I just did sort of like the first pass of the insertion logic and wrote a quick test to just assert on like the length of the nodes vec. So we're storing all of the nodes in a vec, just sort of arena style allocation where we pre-allocate memory up front, much more than we need. And then we just move, we insert in nodes and refer to them by their index, which is a pretty common way of doing it. Now, lots to talk about in the implementation. Lots to talk about. A lot of bugs. And one of the reasons I was made aware of this is the test at the end. It showed, I think it was 14 or something like that. I haven't run this in a bit, but yeah, effectively 14 nodes for a 24-bit prefix. And again, we're doing a naive binary tree right now, so there should be 24 nodes. There actually should be 25, given that the first node that we're inserting is sort of like the root node before any of the we look at any of the bits. So it should be 25. And so I was just reading this a little bit, and I uncovered a few interesting bugs. There's a few major ones, and one of them is the reversal of this bit iteration order is just not necessary. I think this is like a byproduct of the fact that I constantly forget that endianness has, well, for one thing, isn't even represented once you've converted it to use size, but even if it did, it's at the byte level and not the bit level. So I constantly forget that. So iterating from 0 to the end of the value is correct. You want to iterate in that order. You still in short, the most significant bit. This is not correct. The most significant bit is the left-hand side. So I'm actually going to kill that. I'm also going to kill this. This is also misleading. It's not converting to little endian. I mean, it's being converted to little endian in the sense that that's how U32s are represented in memory, but that has nothing to do with. That's an internal thing. Like, we don't have to care about that. The left-hand side is still the most significant bit, and iterating from left to right it doesn't care about endianness. That's just a something that's handled for us effectively. The one correction I was going to make is also, like, if I wanted to go from 0 to 31, I should have made it inclusive. So that's one thing that I could do. But instead of actually doing that, what I'm going to do, and this is another potential bug, and would have been uncovered if I had even gotten to this point. We really should be iterating to the prefix length so that we don't overshoot. And this is, I think, already use size anyway, so I don't need to do this. So that's great. And then here, we just simply need to do, yeah. So we're still shifting left. 31 minus, yeah. So that means this is correct, because here I will be 0 at first. So what happens is, the 32nd bit, because it's 31 minus 0, so we get 31. So that's like the leftmost bit is being shifted all the way to the right hand side, which is what we want. And then when that increments, 31 minus 1, that'll be 30. So it'll be the second from the left. That shifts all the way to the right-hand side. So that's the whole idea, is that for every bit that we're looking at, we want it to shift all the way to the right-hand side, because that's when we are ANDing it against 1, and then we're comparing that against 0 to figure out if that bit is indeed a 1. So that's correct now, now that we've fixed the actual iteration order. Yeah, hold on, let me just mark down. I have some of these noted for myself just to make sure I'm tracking them. And then some of the bugs are actually downstream bugs of the other bugs that might already be fixed. So that's correct. Right. Oh, yeah, I forgot about that one. Yeah, that's whatever. That's silly, but all right. Yeah, we got to take a look at this. I think I might need to do something there, but I don't want to dive into that just yet. So we are Yeah, so that's taken care of. Cur node equals new node IDX. Is that right? Cur node equals new node IDX. I had a note for myself earlier. Route is only new node branch. I mean, so I think we need to look at where cur node is updating. Oh. Well, here, I think, is where the problem is. So we're not actually updating cur node here, and I think we should. But probably after this. So we're saying the cur node dot write is the new node IDX, but then we need to, yeah, that's right. That's right. That's right. This is what I was missing. Cur node equals new node IDX. Okay. So here, actually, I think this is fine, because what we're saying here is we're saying, you know, I'm going to add some helpful comments. Is the current bit 1, 0, or 1? Divide the next node based on this. And then if then traverse into it. I'm going to remove this comment. Okay, so then we want to now is this right now? So let route equals, if I equals 31 minus entry.prefix.plen. No, I don't want that, because this is, yeah, I want to know basically is I equal to the prefix length minus 1, because that means we are at the last bit that we are considering, which is fine. And then, yeah, so then if it doesn't, next node doesn't have a child, so we need to insert a node. Do we also insert a route? At this node? And so then we say allocate a new node and link it to the current node. And then set cur node to the new child we just created. Okay. Yeah, that'll help me keep things a little bit straight. Sometimes I wait too long to add comments just for my own sanity, especially if I've changed a bunch of things recently. Okay, so I think that's pretty good. I think that fixes some of the obvious stuff that we did. I was just thinking maybe that, yeah, this is where I lost track of which bug was causing each other, but that's okay. Let's actually just rerun this test again and see if we can get, should be 25 is the length now. Oops. $25. Woohoo! Excellent. So actually, I'll just do this for now. I always forget how to. Well, I'll just do that. Yeah. So then let's just make this a little simpler. Assert equal 25. Excellent. Okay, so that's fine for now. I definitely want to go into more detail on that. Let's see. Yeah. I think we can consider all of that closed out. So yeah, I have a few more ideas for testing. And I suppose like the most important thing to do is to start thinking about, well, we'll probably have to implement some basic traversal, similar to what we would do for lookup, but I don't know how much of that I'll need just yet. The one thing I also wanted to do was just add some helper functions here just to keep, because I imagine I'll want to add more routes here very soon. So maybe I'll just add some quick parsers. How do I want to do this? Probably. Prefix and ranges. I mean, if I think about how I would lay that out, it would be something like let route stir equals, be something like 10.1.2.0/24, and then you could say comma, and then what's the format we want to like really represent these in a string? Maybe something like 1000 to 2000. If I do the comma is not super necessary, but it does make things a little easier because I could split on the first bracket. But the other thing to keep in mind is you might have more than one range, and so like we probably want to comma delimit those. So 3000 to 4000, something like that. Then I don't know, maybe the pipe operator for that, just to make it easy. It's not the like yeah, it's not the best, but I mean, it does allow you to display it on one line. I could also just make the argument that this should be in JSON. But I don't know if I want to go there just yet. I would say like we could probably just do this for now. and then change it later. Because I think, again, I only want to do it like in tests. So let's actually make this a vec just for tests. And then I'd say let mute routes. Vec prefix and ranges equals vec. No, let's not do it that way, because we could just iterate now. So let's say like let routes equals routester.iter, and then I would say probably map here. So we have our individual route string, and then we say let prefix equals f.split. We'll split at the pipe. Oops. And what, I think the nth? Yeah, nth. So we'll do 0. And then we'll say let ranges equals f.split .nth 1. And then man, this is, yeah, a lot of splitting. That's all right. It's going to be messy at first, but I'm just trying to get through having something that makes it easier to test. Let because this is just for one, right? Yeah. So let prefix adder equals prefix.split /.nth 0. Nope. Let prefix len equals prefix.split .nth 1. Let, oh my gosh. Let, so we got the prefix adder, we got the prefix length. We need to obviously parse both of those. And then, but we also now need to parse our ranges. So let, we already have ranges, the string. Oh, interesting. Let's just get rid of the brackets. Yeah, I mean, I was gonna trim it off myself, but we just don't need it. We're already splitting on the pipe operator, so then we have commas and we can split on those. So let so we have ranges split on that. And to be honest, let's actually just do I'll have to do an unwrap here, and then we'll do a split again. And it's just split on the comma so that we can have our iterator just right here. Yeah, actually, let's just keep going on this. Like, so iter, oh, is that right? Can I do it that way? Yeah. I always forget how the split iteration works. Yeah, I mean, just into iter should be fine. And then we say map. Let me make this a little bit more sensible. Actually, yeah. I don't know why it's not formatting for me. This is very annoying. What on earth? Oh, because I left that dangling let. Oh, and of course this isn't gonna work. So prefix. Let's just do an unwrap here. The formatter's freaking out because I have too many errors. So that's fine. So we split into iter so that we have our format string. Oops. So we have our format string. Not format string. We have the string that represents each individual range. And so then here we say f dot. So we want to return a port range here. Port range high or low equals f dot split on the hyphen. And then nth equals 0, and then we'll unwrap. Again, this is just for test, so it's fine. I'm gonna add a proper. This is actually taking a lot longer than I thought that it was gonna take. I definitely will be adding like a proper from string representation with error handling and all of that. But before I do that, I want to put more thought into like how I actually want these strings to be formatted. And again, I'm not convinced that I don't want JSON. I just figured this would be faster, and it's proving to not be much faster. What's going on? Use 16 type the. Oh, right. Okay, of course. So so we've got that, and then U16 U16 from stir, and we'll have to unwrap this as well. So we have our port ranges. Oh, we don't quite have them because this is still an iterage. So let's tie that off. I think we're just ready to collect. So did I declare the type? I probably didn't. No, I did not. So let's turbofish this. Actually, I don't. Well, I usually am kind of split on how I'm usually kind of split on how I want to do this. I don't hate the turbofish syntax. But I almost want it to be in both places, like declaring it up front, like at the top, and then also declaring it down here with turbofish. Yeah, whatever. So let's do routes, and this will be a vec. No, not here. So ranges is vec of port range. That will fix the error, and I suppose that doesn't look horrible. It's pretty close anyway. I just hate it when there's like the type declaration up top, and then maybe there's some closures that are much longer, and so like the actual collect at the bottom, and when it doesn't have the turbofish, but then it doesn't really apply in this case. There's not it's not that complex of a conversion. Okay, so we have our vec of port ranges, and here also, I mean, same. We're gonna have the same problem. So let's just fix that now. vec of prefix and ranges. And we're going to get a ton of errors because we haven't done anything about that yet. And so I'm actually just going to undo that because it's annoying. I will obviously do that here in a bit. So we have our prefix adder and len strings, but they're still strings, so we need to fix that. Prefix len we can also do convert here in the moment, so unwrap. And I really should have invested this time in just making a proper frumster implementation, or looked into like storing it in JSON or something. Because the truth is, I'm not going to want to validate any more than one route anyway. So like the routes below, this was probably not a good use of time. And then dot unwrap. I'm going to also just declare this as a IPv4 adder. Dot parse dot unwrap. Okay, so now I keep doing that. So now the last thing we need to do is we need to return a prefix and range. And this is IPv4 prefix. Right? Oh, actually, sorry. I have the constructor for that. So let's use it. And yeah, I think it's prefix, and then I think it's port range or ranges. Oh. Prefix adder, prefix length, prefix. Oh. Right. I haven't actually converted that just yet. Prefix and ranges, new, prefix plen, and then that should work. Why does it not? Prefix adder is why. Oh, man. Do I seriously not have a constructor for that? Yeah, I do. IPv4 prefix, yeah. I don't know why I didn't use it below. Okay. I named it prefix len. And what's wrong now? Expected U size found U16. Okay. Yeah, I mean, that definitely doesn't need to be a U16. Okay, now we can do what I wanted. So we end that, and then we can do vec prefix and ranges. Expected vec and prefix and ranges, found struct map slice iter. Oh, collect. Okay, finally. My gosh. That was just not a good use of time. Sure. Let's just rerun the test to make sure everything's fine. Oh, that's right. We added the assertion, so that's fine. Okay. So let's go a little bit further with this now that we have this. Now that we have this, not even like totally temporary, not even good Frumster implementation, if you will, with like unwraps to last until the end of time. So we're asserting that this is 25. Let's do another like helper function that lets us actually walk the path. So walk tree. Let's say right. Let's just make it a reference to keep it simple. And then let's see, the address is probably, we'll just do like a IPv4 adder. This is the one we're going to look up. Do we want to look up like a particular prefix? That's probably what we want to do, actually. That's probably what we want to do. Because we're validating that the prefix is what we want. We're not actually doing a real lookup. We're doing a traversal to validate the prefix, basically. Prefix. And then what I think I want to do here is the index of the final node, because I want to validate that that's at the right place as well. Or actually, yeah, I mean, I kind of just want it to give me that last node and make sure that the property of that is correct. So let's do usize. Well, it might not be there. Like the route might not be there. Well, let's keep it as usize for now, because I don't think we care about the route in this traversal. We're just returning whatever it is. So let mute cur node equals 0, and then for I in 0 plen, not plen, prefix.plen, we will then do the bit traversal. So same kind of thing. So let cur bit equals adder shift left, and then we're going to do the same logic as before, 31 minus 1 and 1, or, well, right, that. Right. So if bit equals 1, then we want to go to the right. So, well, we want to set cur node is actually here. So if bit equals 1, we want to set cur node to try.nodes, right, try.nodes. This is then cur node dot right, and if it's not, cur node equals try.nodes, cur node dot left. Right, so then the last thing we want is to just return the index, which is cur node. What are we having? What are we having here? Open. Right, prefix.adder. So what did I do here? Is it not already is it already not a U32? No. I think I had to convert it here. Yeah, that's right. Let's just borrow that. That's, I think, why I had it in mind that I wanted to use adder. Ah. And then here we can then just use adder. Which means then this needs to be curbit. And cur node equals probably we want to unwrap here, I'm guessing, because if we want to, if we know, yeah, we probably want to unwrap, because I'd want the test to panic if the bit says we need to go there and there's not, and there's a none there, then yeah, we want to unwrap. So what's now? Expected use size found. I don't understand why. Option use size, so unwrap. I don't understand. Why is it? Yeah, like, what? What? Oh, pff. No, that wasn't it. Mismatch types. One. Oh, I mixed up what I was doing. So these, sorry, yeah. So I'm setting cur node here, but I'm relying on it to be returned. That's fine. Okay, my gosh. So walk tree. This is important because this will assert all along the way that the tree is how we expect, based on how we need to walk it, and then it will return the current node. So then we'll use this. So we'll say, okay, we've asserted the length, but then let's actually walk it. Walk try, and this is, and then prefix is IPv4 prefix. I thought I had this as a constructor. New. Yeah. This, no, not new, from stir, and then we'll do 10.12.0 or 10.1. It's a 1. 10.1.2.0. And then 24. IP4 prefix that new. Did I miss a? Oh, I did. Okay. So then that asserts that, but we also have let final node equals walk try, and then we want to ensure, oh, you know what would also be useful since we're validating just a single prefix. I don't know if we want to keep this here, but certainly for now we can, because we're just validating the one route. Let's assert that try.nodes cur node dot route dot is none. And because we don't expect any of them to have a route except for the final the final bit. And this will remain true until we start adding overlapping prefixes. So that's another assertion that we're making along the way. And so then what we want to do here finally is we want to assert try.nodes final node equals dot left dot is none. And then right, and then also the route is sum. So what this does is a bunch of things, actually. We are first asserting the expected length just based on the prefix. We know it's 24, so 25 should be the length of the actual node's vec. The iteration that the traversal that we added here does a few assertions on its own. It will assert that every node along the way has none for its route. This will fail right now if it is the last node, so we actually want to skip this if I is less than prefix dot plen minus 1, but otherwise it's fine. So then and also the unwrap here is great because it makes sure that all of the nodes along the way have a sum value for the one that we're traversing into. So obviously one of them will be none, but the one that we choose to traverse should always be sum. So that's a lot of stuff that's handled by that. And then finally, when you do get to the final node, we do some assertions based on for that. We assert that it doesn't have any children, and we assert that it does have a route. It's not just an intermediate hop, an intermediate node. So yeah, good stuff here. Cargo test. Sweet. Okay, great. A lot of work to get that string parsing in there, but fine. So I think that's pretty good. The one thing I know that we haven't handled yet, and I don't know if I want to handle this now just because the string parsing took so long. The port ranges are something that we haven't handled yet. And this is another thing I just neglected to think about yesterday. I was expecting that I wouldn't need to clone this because it's just the port ranges are just U16, and so they automatically implement copy. The struct doesn't, but I did derive copy on it. The distinction, though, is that this is actually a vec of those. And vecs are heap allocated, so they do not implement copy. So I got to think about how I want to do this a little bit. It's probably fine for now. So I'm actually just gonna I'm just gonna treat this as sort of just like an optimization to make later. Plus, this is on insertion, so I don't think it matters too terribly much. But where did we get this? So entry, we're being given the entry. We're being given the entry. So really the question is up here, because we are being, well, we're being given the entries because we're passing it in the constructor. So how do I want to do this? I think this goes back to what I was talking about yesterday, where I'm not even sure where add port range to this. Input to this constructor likely needs to be a new struct which contains both. Is this comment old? Yeah, this comment's old. Because it already is. It already is now. Prefix and ranges includes that. So prefix and ranges is already a vec of port range. And as we saw in the test, we're creating these prefix and ranges here. But I wonder if maybe we should just do this in the constructor. For prefix and ranges. I don't think we should, though. I don't think we should, because it's the try that needs to be sorted. I'm probably not doing a very good job of setting the context here. So we need the port ranges to be sorted, because we're going to do a binary search as part of the traversal. And not only that, we need to make sure they're non-overlapping. So the question then is, should that be handled outside of the try constructor or inside of it? And if inside, then we'll probably have to clone it as we go, right? Because we're sort of allowing it to be declared outside. And as we are iterating, well, we don't have to clone it. We're literally taking ownership of it, and so we can sort it in place or return an error from the try constructor. So that's really what we need to do here, is we need to handle it here in the try constructor. So for every entry, we need to check the port ranges for overlap first and return error. Otherwise, sort them in place before passing to insert. Yeah, I think that's the right call. Yeah, so probably, well, let's just keep it immutable for now, because I don't know if I want to go that far yet. Let's check overlap. And for that, right? Ranges. Let ranges equals entry dot port ranges. So that's our vec of port range, and we are then going to say, this probably needs to be in a method, but on what? Well, I don't think it needs to be in a method. Let's just do it here. For range in ranges. So let first cur low, cur low equals 0 u size, 0 u16 actually, and then let cur high equals 0 u16. Well, actually, probably want u16 max. I'll change this if I need to. Keep doing that. I need to disable that. I actually don't like that key combination. So for range and ranges, what we're doing here now is we need to say does the... Oh, you know what actually would be really useful is just to actually enumerate this. And then we can say for I range, if I is 0, that means it's our first range. So that means cur low equals range.low. So that's the new, we don't need to check it against anything. We know it's the first one. Oh, you know what would be ideal is to actually sort it first. Because, yeah, we haven't sorted it, so there's no guarantee that. But how do we sort it if it might be overlapping? See, that's the... Yeah. Interesting. Should we sort it first? And if so, based on what? Well, we could probably do it both. Yeah, I think this is what I was thinking earlier. So I know that at some point for the traversal, we want to do a binary search. So there's this binary search by on the slice that you could use. So one thing we could do is actually scrap all of this and just do build the new, like build the ordered vec. A little bit wasteful allocation wise, but we could build the ordered vec as we go. And what I mean by that is you could actually sort and overlap check at the same time. So we'll create a new vec. Let me write this out because I'm actually just gonna kill all this. We've got the ranges, that's fine. Let's call it input ranges. And then we can do let mute sorted ranges. And this is a new vec port range. Yeah, this is the wasteful part, but it'll just help me make sense of the logic here for now. And then we'll do vec with capacity, just to at least make that sensible. And then we'll do input ranges.len, because they will be the same size. We won't be changing the size. We just might be bailing early if there's an overlap. And what's the deal here? Oh, just unused? Yeah, that's fine. This we want to make a reference because we're going to be leaving that in place, and we're going to be changing this anyway, or really creating a new entry. We'll be creating a new entry. Well, actually, why don't I just clone this now? Well, I don't know. We'll move things around here in a little bit. The one thing I wanted to do is binary search by. Yeah. So the slice binary search by will help us. And the reason it'll help us is it actually returns the index of where in the vec the item you're searching for would be inserted if it were to be inserted and to be in order, like if it didn't exist, which means that we can then insert it, and then it'll be ordered. And I think as part of that closure, we can also check to see, or I guess immediately after that. Yeah, that's what we'll do. So we'll do the binary search by to insert the port range at the right spot, and then we will take a look at the neighbors of that, because there could be neighbors on either side. We'll do the overlap check right there. So yeah. Yeah. You just need to check both sides of it. Yeah, you need to just check both sides of it. So we have sorted ranges. Again, this is a little wasteful, but that's fine. So then for input range in input ranges, this is the range that we are considering inserting into the new sorted ranges. So we will say sorted ranges dot lost my train of thought. Binary search by. Yeah, binary search by. This is a great. I love this method. You can give it a little comparator function too. It's just really useful. And again, it gives you the index back. So you say, okay, sorted range dot binary search by, and this is your closure. So let's say this is our port for the port range we're looking at, and then you say if the r.port range, this is the one we're looking at, right? This is the one that we are looking at in the actual input vec. If r dot low. Oh, does this? I don't know if we can even necessarily handle the overlap. We can try. I haven't thought this through to the end. But if r.low is less than man, I'm getting lost, I think, in the things, in the parameters. So I'm just going to write some notes down. So R is the port range we're looking at in the sorted ranges vec. We need to compare it against input ranges, or against input range. So if the input range low is, or if the input range low is higher than the r dot low, or r dot high, I guess. Yeah, this is where I'm not sure if we can actually check for the overlap here. We might need something a little smarter. If r dot low, I'm gonna have to bail here in a little bit too. If r dot low is greater than, let's make it reflect the comment, because I think that makes more sense. So input range dot low is greater than r dot high, then the ordering should be greater. Because, yeah, it's greater. Else if input range, yeah, I'm still not satisfied that we can do the overlap here. But I'll at least do this assuming there's no overlap, because that if you know there's no overlap, that becomes a lot simpler. Range dot low is less than r dot high. Yeah, I mean, I got to put more thought into this, and I can just tell my attention is going elsewhere, so I think I'm going to call it here. I'm going to, instead of doing this, I'm just going to add a note. Need to implement here. Can overlaps be detected this way? Or do we need to reject overlaps first? Yeah, just my head, I can just tell my head isn't keeping up with the latest things. And just to satisfy this, let's just ordering equal. What? Found enum result new size. Wait, what? Yeah, Bruce says, it is a result. Okay. If slice is not sorted, the comparative does not order consistent with the sorter of the underlying slice, the returned result is unspecified and meaningless. If the result is found, that's right. Yeah, I'm looking at the docs here now too. Yeah, because I need to return both. It's telling me that I need to return search by probe. No, but I don't need to I think yeah, I'm not returning the result. I'm just yeah. That's fine. So I'll handle that result later. But yeah, you just need to return the order. Okay, so for next stream, this is what we're gonna do. Okay, man. Yeah, so my cognitive faculties falling off as I have other responsibilities approaching this morning. But yeah, I'm gonna put more thought into this. Part of it's not even just the details, but also just not being convinced that I've done this the right way. Like, again, do we need to reject the port ranges first, or can we do it as part of this? And I need to think through that in a different headspace. But anyway, thank you for watching, and we will see you next.